Get that. Okay, so I don't want to prove that one, so I was just talked it through a little bit. We were talking about principle 6 here, which maybe I should take a roll before I do that. What do we got? 20? Yeah, we got just about everybody's here, so let me make sure I know who people are. So I'm going to insert a column for today, which is the 17th. Yay for 17. I put that in the wrong place. I need to move that cell to the top. Okay. And maybe remove its hyperlink. Somehow it got a hyperlink. Okay. Okay, I'm just going to ignore that then. And we've got Adrian Aguilar. Are you in the house today? Maybe let me get up the chat. See who's here. Have you taken roll yet? No. Good question. And recording. Yes, thank you. And looks like Adrian is not here. Okay, not yet anyway. How about Brianna Contreras?
I'm here.
I see you. And Dylan Dorado. Dylan. I do not see a Dylan. Okay. How about Xavier? Yeah, you were early.
Yeah, I'm here.
Yeah, great. Blake Intravaya? Not here yet. Kevin Jimenez? I do not see Kevin. In fact, we haven't seen him all week. He may be a thing of the past. Ida Leva? There you are. I see you. Sort of. I see a box with your name on it.
Yeah.
Great. And Tiana Lizarraga? Tiana Lizarraga. There's Dylan. Okay, I'm going to count you as present, Dylan.
Oh, I'm here.
Yeah.
Sorry.
No worries. Tiana is not here yet. Okay. How about Jacob Lopez? Yep, I see you. Lola Lott? Yep.
I'm here.
Great. Carla Medina?
I'm here.
Mm-hmm. And Andre Mejia, I think you were also early today. Yeah, and or you were early to the chat. How about that? Taylor Milligan was early. Good. Kelly Meyer was the first in the door. Kyra Moreno. Yeah, I see your celebrity square. That's good. Mary Richarte has a celebrity square. Sure enough.
Yep, I'm here.
Great. And Roberto Rivera Gonzalez.
I'm here.
Great. And Carla Rivera. Yep.
I'm here.
I hear you. Leonardo Rodriguez. I do not see. How about, yeah, I haven't been here for a few days. Maria Kaito.
Here.
I hear you. Melissa Salazar Romo.
Right here.
Okay, great. And Gail Salgado.
Here.
I hear you. And Luis Angel Cerrato. He wasn't here yesterday. Okay. That would be a shame if he's not going to join us. Archana Sethi?
Here, I'm here.
Oh, great. And Santino Starian, AKA Sethi. Not here? Kaya Weaver.
I'm here.
I see you. And Jasmine Williams?
I'm here.
Great. How about Jadzia Woods? Yep.
I'm here, Professor.
I hear you. And Tia? Not yet? Oh, no. Not yet, huh? All right. So let me demonstrate how we might, anybody come in while I was taking roll? Um, I see Andrea Mejia. I have a question about the discussion. Yeah. What's your question? You can either chat privately your question, or maybe I'm going to address that issue right now. So let me demonstrate one way of doing this. There are others, right? But I have a camera, which is my DocuCam, right? And where is that? Here, right? So if I go to speaker view and focus on me, I can see that here. And I see that we have principle 7. The diagonals of a rhombus form 4 congruent triangles. Yeah, that's very closely related to what we have. I mean, it follows sort of immediately. So let's move on. I want to find one. How about principle 9? If a parallelogram has one right angle, then it is a rectangle. Yeah, then they're all right angles, right? Thus, if you have opposite sides parallel and one interior angle is a right angle, then they're all right angles. Okay. Let's go ahead and prove that. Okay, so this is principle 9, which I mean, actually, the number of the principle has no bearing. You're not expected to memorize the numbers and refer to them by number. Just have the idea of it and refer to it by the idea. So principle 9, as it's called here, if a parallelogram, and that's I found this notation today, which I kind of like. Right, it's parallelo is a sort of it's it's got 3 L's all together. There's 2 together, and then there's 1 by itself. Parallelo, right? And that's a lot of trouble to write. So I like this notation because it's got the 2 little parallels here, right? So a parallelogram, there you go, has 1 right angle. Then it is a rectangle. So what's the definition of a rectangle? Oh. Is it the opposite sides are equal? We got to go back to getting the proof, right? So here we are about here. I'm going to go back to the beginning. This is the very beginning, right? Trapezoids, trapezoid principles, parallelograms, principles involving parallelograms. Okay, where was the rectangle? I think it's a special parallelogram, right? So a rectangle is an equiangular parallelogram. Okay, and so we're at principle 9 here, where I'm sorry, I'm scrolling here and you can't see what I'm doing. So I went back to look for the definition, and I found it. And it's equiangular parallelogram. So 6. Okay, there it is. So recall a rectangle is an equal. I mean, there's different equivalent ways of describing it, but the definition we're using is a rectangle is an equiangular parallelogram. I'm going to use that abbreviation for parallelogram, right? Okay. So we want to show that if the one angle is a right angle, then they're all right angles. So the plan is going to be what's our plan? Interior, use interior angles on the same side of a transversal are supplementary. I don't know. Do you have a better idea? Let me know. I'm open, but I think this is going to work, right? So I'm going to draw a parallelogram. The smaller, well, they sometimes fall on the floor here, and then they become invisible. I prefer that smaller. Oh, here it is. It sits on the page better, right? So I'm going to draw about, no, that wasn't very dark. Do my best to draw a reasonable depiction of a rectangle, right? And we have one right angle, and we know that it's a parallelogram, right? If a parallelogram, right? So that's given that it's a parallelogram and it has one right angle. So to indicate that it's a parallelogram, I'm going to draw these arrows to show those are parallel, right? And label some vertices. So then I'm going to have a statement and justification. And boundary here. Good luck keeping within those boundaries, but we'll try. So what are we given? We're given parallelogram, and we can also indicate a parallelogram with a little picture, right? A, B, C, D. That's given, and angle D equals 90 degrees, by which I mean the measure of angle D, right? That's also given. So now we know that AB is parallel to CD. How do we know that? Well, definition of parallelogram, right? I love this new abbreviation. It's always been a pain for me to write the word parallelogram because it's all those L's climbing over each other. All right. All right. And then so we know that angle A plus angle D is equal to 180. So that's following our plan, right? So I'm going to say that same side interior angles when AD cuts AB parallel to CD. Yeah. Okay, and then I can substitute for D, it's number, right? So that's simple substitution principle. You can always substitute something equal for something. So angle D is equal to 90 degrees, so I can substitute 90 degrees. Then I can use the subtraction principle. And subtraction property of equality, which is that if you subtract the same thing from both sides of an equation, you get an equivalent equation. How are we doing? And so now we have two of them are 90 degrees. And I'm going to say, I'm going to stop the justification. I'm going to say similarly, angle B equals angle C equals 90. It's the same argument, right? So I don't have to repeat that whole argument, do I? It's, yeah, I mean, they're C and D are same side interior angles when CD crosses AD parallel to BC, and C and B are same side interior angles when BC crosses AB parallel to CD, right? So it's all just the same argument over and over again. And that's what we were to prove, right? So, so I can say, I don't know, am I done? Do I have to say anything further? I mean, by definition, all the angles are the same, so it's equiangular, and so it's a rectangle. So I'm going to say parallelogram ABCD is a rectangle, and that's the definition, right? It's an equiangular parallelogram. And then I can say QED because I'm done. All right, so the point of this was, I mean, this is a very easy proof, I think. But the point is to then say, how do you scan this as a PDF, right? So I want to take a good picture. So I'm going to take my camera and try to focus in on the important parts in a way that makes it sensible. Okay, and I'm going to get rid of me for a moment. So I don't have that in the way. Oh, wrong correction. Huh? I guess I want it to be even farther away. Okay. And I'm going to have to make two pictures the way this is set up. And so now, depending on what kind of a machine you have, you know, you need some, yeah, go ahead.
Friend offers to allow Officer Kovac to search her house, even though she is under no legal obligation to help the officer. After Officer Kovac informs Ms. Morales that he will be writing her daughter a ticket, she rescinds her permission to search, even if Officer Kovac had.
Okay, Xavier, we were hearing that somehow you were unmuted, so I muted you. You want to mute yourself, and then. Okay, I guess you did, right? Okay, sorry. I thought maybe you had a question, but maybe you're multitasking, which I've been known to do, so I'm not going to call the kettle black. So speaker view, okay. Oh, somehow I went full screen. I didn't want to do that. Crap. So how do you get rid of full screen? It's not obvious to me how to do that. So unpin video, more, no. Can I? Okay, well, I mean, okay, exit full screen, all right. Okay, so I have a reasonably good angle on this, maybe a little better. You know, so you want it to be sort of straight down and the lighting to be good and it to be focused. All right, so now on Windows, depends on what kind of machine you have. I'm not quite sure how this works on Mac. You need some way to sort of capture your screen, right? So on Windows 10 anyway, you can go Shift, Windows key, Shift, and S will get you a snapshot. And so then, yeah, it's a little darker when I do this. All right, I'm not sure why it's darker, but I then can drag something around my window, right? And so now I have on the clipboard this picture. So what do I want to do with it? Well, in Windows, you always have Paint, right? Or if you have Word, that's good too, right? So either Paint or Word is good. If I go to Word and say Control V, it'll paste that in there. And it's not a great picture, I gotta say. It's a little dark. I think I should have made it a little brighter. But let me get the rest of it now. So you can't see my Word document, can you? I just opened a Word document and said paste, right? Can we show you how to do that? I think we can. So the way I hate to spend so much time on this, but this is sort of an important aspect of what we're doing. So if I go to my browser, right, and say I would like to go to Office 365. And I think you should have this as a student somehow, be able to get to Office 365. And then I can say, yeah, I want a Word document. I guess I want to launch this first, right? And then say, yeah, I want a Word document. You see that over there? And so new blank document. All right. And then if I say Control V, it takes a little while to think about it, but then there's that picture, right? And I got to say, I'm not terribly happy with the picture because it's a little dark, but it's okay, right? And I'm then going to capture the rest of it. Okay, so let's go back to our cam and say, all right, I want the rest of this, right? And I'm going to try to change the lighting a little bit. Can I make this a little brighter? I think that's okay, right? So then I just want to capture that, right? So I'm going to, now on Windows, if you have like Windows 7, or yeah, you're going to have the snippet tool. That's what, when I say Windows key Shift S, I'm getting the Windows tool. The capture tool, the snippet tool in Windows. You can also just start typing. You hit the Windows key on the lower left and start typing. Snipping tool is what that's called. And I could do it that way as well. That's sort of the old-fashioned way, right? Try snip and sketch. Okay. So, so they want me to try this other way of doing it, right? But I can also say new capture, right? And then I'm going to go down here and try to capture the essential part of what's here. Okay. And I can say copy that. I don't know if I need to, or if it's automatically on the copy board. But then if I go back to my Office Word page, right, I can paste that in here. Oh, came in. All right. So you can see that's, a little better contrast, maybe. I don't know. It's, yeah. Obviously, I'm not a perfect photographer either. But I think maybe this, yeah, that kind of fits on there, doesn't it? Yeah. And this kind of fits, you can actually stretch this out if you want. And then I can save this as a PDF. So file, save as, download as PDF. I guess that's what, you don't see that. Oh, you do see that menu? Wait, I'm seeing a different thing. Oh, I see that. I just have the snippet window obscuring. And Let me get rid of that obscuring thing there. Okay, and it says, yeah, your document is ready. I'm going to say download. And so then I get a menu which you can't see. It's a little pop-up menu that says opening the PDF. I want to actually save it. So I get the option. I could open it in Firefox or I could just save it. I want to save it. And I need to save it to the directory where I keep my trigonometry stuff, right? That will be different for everybody, right? I have mine, you have yours. And you need to give it a name. So I'm going to call this principal 9 proof. Okay. Then I'm going to go in my browser back to here. And then I would hit reply, right? And then I think I can either insert, edit media. Can I insert embed, advanced, general? So, I see. So I guess I didn't quite get how that works. All right, so this is insert media. This is link to URL. Okay, so embed image, I think that's what I want, right? It's this choice here, the embed image. Okay, and so I need to, I guess I need to upload that file. So I haven't done that yet. If I go to Canvas, I can say upload file. I think I need to choose what I wanted. So then I can say upload, and it gives me, you can't see this. I get a pop-up, a window pops up, which is my directory where that is, right? And I want to look for principal. I should be here. I'm not seeing it. They're alphabetical here. Oh crap! How come it's not here? Oh, because it's not a PNG image. And I want to. I guess it'll only take a PNG image here. Really? I was hoping for a PDF to be able to upload a PDF. Okay, so I'm going to take another approach here. Yeah, not making this look easy, am I? Sorry. Let me see, is there anything going on in the chat here? After finishing this example, can you explain the diagonals? Okay, yeah, sure. So I guess I need to go to Files over here. Do you see the Files option on the ribbon on the left? And I can say upload a file, and then I can upload a PDF, right? And you can't see that I'm looking through a directory that contains principal 9 proof, so I can open that. And then you see it's there, right? So I uploaded that file. And I guess I'm going to then go to modules, go to scan PDF and attach, right? So then I'm going to reply, and how do I insert that file as my, so I think I can go to, it's not a page, is it? No. Okay. So what are my options? I can embed image. Well, it's not an image, right? It's a PDF, right? So is that media? Let's see. Start typing principal. It doesn't come up with anything. Embed. No. Okay. So I can go down here and say attach. I was hoping to actually embed it as, the thing right in here. But, the other option, you don't see this if you're just looking up top, right? At the bottom, there's a little paperclip thing that says attach. And I can say, yeah, browse. Oh, and then I didn't actually have to upload it because I can just get it from my directory on my local computer. So then here I responded to my own thing here. So don't respond to this, respond to the original prompt, right? But if I open this now, does it come up as a thing we can look at? Yeah. And it takes a little while to load. Oh, I guess there's nothing on the first page. That was my bad. But yeah, so you can see here's a statement of the principle. Here's my plan, a little diagram of what's given. We're given parallels, opposite sides are parallel because it's a parallelogram. And we're also given one right angle. And then we go ahead and prove. So you want a hint about, okay, so is any questions about that before we leave this? And then Taylor had a question about the actual thing I want you to do, which, I hate to encourage this, but I mean, you can just look it up, right? Is it one of these guys? Proof that the square, can I just look on here for rhombus? Oh, it doesn't have rhombus. Okay, so geometry. Let's see. We can look for rhombus again. No, they don't have rhombus. Okay, so we can just search at the top here, right? Rhombus, diagonals, perpendicular, bisector, and looks like I've already been to this one. I think theorem 7 is actually pretty good. Theorems about parallelograms. Theorem 8. A quadrilateral is a rhombus if and only if the diagonals are perpendicular bisectors of each other. That isn't quite what we want, is it? But it's going to have some of the ideas. So given a rhombus, we want to prove, yeah, okay, so this is it here, right? I would say don't just blindly copy and paste, but that contains the essence of what we're after, doesn't it? So we're given a rhombus. We know that the opposite sides are parallel because, not that they're congruent because that's the definition of a rhombus. And we know it's a parallelogram because the opposite sides are congruent. Okay, sure. Is this like our definition of a rhombus? You have to be careful that you're consistent with what we're doing, right? So what was our definition of a rhombus? Was it an equilateral parallelogram? Or just an equilateral quadrilateral? Equilateral quadrilateral. So for that, maybe we want to go to our book and see, whoops, where is our book here? Okay, and I think the definition, a rhombus is an equilateral parallelogram. Okay, so we're given not only is it a parallelogram, so we get everything that a parallelogram has, which is opposite angles are congruent, opposite sides are congruent, but it's not just the opposite sides, but all 4 sides are congruent for a rhombus, right? So there's that extra feature of a rhombus. And so if we go back to our proof here. Where is that? Here. Yeah, so ABCD is a parallelogram. The opposite sides are congruent. But we don't have, for our definition, we know that by definition, ABCD is a parallelogram because it's an equilateral parallelogram, right, by definition. So the diagonals of a parallelogram bisect each other. We proved that already, so we can use that now, right? So we get that the diagonals are bisectors. We've already proved that. So then BE is congruent to itself. Where are we looking here? BE, this little side here, is congruent to itself. We know AE is congruent to EC because the diagonals of a parallelogram are bisectors. And we know that AB is congruent to CB because it's a rhombus, right? It's equilateral. And so by side, these two adjacent angles are congruent. So that means that AEB is congruent to CEB. And there's your old CPCTC. And if supplementary congruent angles, if supplementary angles are congruent, then they're right angles, which I might have taken a couple of steps to show that, right? We know that the sum of, we know that they're supplementary because AEC is a straight angle. And we know they're equal because corresponding parts of congruent triangles. So we know that angle AEB plus angle CEB equals 180. And angle AEB equals angle CEB. So I can substitute one for the other. And I have then twice angle AEB equals 180. Divide both sides by 2, and you got angle AEB equals 90 degrees. And so is angle CEB. And so that's perpendicular there. All right. Does that answer your question about that? We need to move on here, I guess. So I'm going to go back to the text. And there's a nice little, diagonal properties for parallelogram, rectangle, rhombus, and square. Square, has all the boxes checked, right? A rhombus doesn't say that the diagonals are congruent, right? Because one is going to be longer than the other. But that is true for a rectangle, right? But for a rectangle, the diagonals are not perpendicular unless it's a rhombus. Or a square, right? Okay, so that's a nice comparison chart. And we proved about 11. If a parallelogram has congruent adjacent sides, then it is a rhombus. So maybe I'll demonstrate this one a little bit differently. Okay. I'll try to do the this time I'll do it with a JPEG, which generally I want to avoid the JPEG, but it looks like it might be a reasonable alternative if you can't get a PDF easily. So principle 11, parallelogram has congruent adjacent. Let's go ahead and prove that. So I want to get rid of this and that, and then to here. So this is principle 11. And it says if a parallelogram has congruent diagonals, then it is a rhombus. Okay. Wait. Oh, sorry. Has congruent, adjacent side. Sorry about that. Principle, I mixed up my principles there reading. Principle 11. If a parallelogram has congruent adjacent sides, congruent adjacent. That means next to each other, right? Not opposite, but adjacent. Then it is a rhombus. Oh, sorry. Okay, and I guess I'm going to go back to the more of an angle here so I don't have my hand in the way and that sort of thing. Okay, and so diagram. Let me use the smaller ruler here. Okay, I'm going to, oh, I got lined paper today, right? Make it easier to draw parallel lines. Try to make it reasonably realistic here. So we know that this is a parallelogram. All right, so I can indicate that with these arrows. And we know that adjacent sides are congruent. And unfortunately, I've already decorated these quite a bit, but I'll put a little little stroke mark on those sides. So A, B, C, D, and so I'm going to say statement. I'm going to skip the plan, right? Because I think this will be pretty straightforward. And justification. And hope there's enough room for everybody to fit in here. And so I'm going to say parallelogram ABCD is given, and AB is congruent to BC. That's given. And I indicated that in the diagram, right? Okay, I'm looking to see if that's reasonably readable. Okay, I think it is. And so what remains? Well, the definition of a rhombus is that it's an equilateral parallelogram, right? So I need to show all sides are congruent. So what can I use here? Yeah, I'm thinking of a plan. I guess, do we need to draw a diagonal? I think we do, right? Or we know it's a parallelogram, so opposite sides are congruent, right? Sure. So that just goes straight for the jugular on this one, right? So BC is congruent to AD, and AB is congruent to CD, and that's because opposite sides, and we proved this, right? Parallelogram are congruent. Okay, and then I maybe say one more thing, right? So I've got, you know, these two sides, but I haven't established yet that AD is congruent to CD. So I can do that as a separate step. And that's the transitive property of equality. Things equal to the same thing are equal to each other. So what? All right, things equal to equal things are equal to each other. So I've got CD is congruent to AB, AD is congruent to BC, and AB is congruent to BC, right? So AD is congruent to CD. All right. And I think that establishes that it's equilateral, right? All the sides are equal. So I can say ABCD is a rhombus, and that's by definition, right? And so QED, I'm done. I've got it all in one picture. Is that a good enough picture for photographing? I don't know. I may want to refocus, huh? I'm sorry. This probably makes you a little bit seasick. All right, so does this focus? Yeah, I think that focuses. So I'm going to refocus, and I think I can capture it there as a, so I'm going to do another capture here, and I think I can grab the whole thing. So I don't know if you can see this, but yeah, maybe not, huh? I'm, using the mouse to drag a rectangle around that with my capture tool. And then you can't paste what's on your clipboard directly into into Canvas. So if I go back to my Canvas thing, I want to see, where is that here? Right. So if I go, I'm going to reply again to myself here and say, Control V. That just doesn't work, right? So I would like to say embed image, but I can't do that either. So I'm going to go to Paint, and I don't know, can I bring up the Paint window? All right, so let me make a new window here. All right, I guess I'll just do window capture. Yeah, you can't see what I'm doing. So this is MS Paint. And can you see that? Yeah. Okay. So this is the Paint window. And if you're on a Mac, it must be, I don't know, anybody on a Mac, I think even on a phone, figure out how to do it. I mean, I don't know all the ins and outs of all the technologies out there, but I'm going to say okay here. And then I'm going to drag this out. Oh, not that. I guess I have to go, where is it? It's here.
Quick question. When's the test going to be?
When we're done with the geometry section. So the hope would be that we can do that next week. Yeah, let's say next Thursday, a week from today. All right, is that good? Good question. Thanks for that. All right, so so now that I'm in Paint, I can say File, Paste. Okay, and paste that in there. Then I can say File, Save As, and it's going to save it in my, well, I guess I have to navigate to the directory where I keep this stuff, right? This is, you can't see what I'm doing when I do that, but I'm going to say this is now Principle 11 proof. I gave it a little name. And then if I go, I'm going to turn that off, and I'm in here, and I want to embed a picture, embed image, then I can go to, I guess, My Files, and upload image, and it's going to find, yeah, again, you can't see what I'm doing when I go to so that you're just navigating to the file where you saved this thing and looking for the name with that, oh, Principle 11 proof. Okay. And so then I'm going to update. And there it is, right? Embedded right in. And it looks like I got, yeah, I didn't capture just the picture part of it. So, kind of a pain in the butt. I like meeting in person, and then you didn't have to fuss with all this stuff. Okay, I guess I need to say post reply, right? And then there you can, yeah, so it's a little bit small, but it's got the whole thing there, right? And presumably then I would be able to read what you turn in and evaluate it. Okay. And with yeah, and so your question apropos the test is a good one, because that's part of why I'm doing this. Is when we do the testing, this is the way it's going to be done, right? We could also do part of it on My Open Math, right? So it could be a combination of, and in My Open Math, you can actually embed an image, right, like this. So maybe we'll practice that as well next week. But let's move on, because we're short. Time is short. And we have a whole nother chapter to cover. Circles. We haven't talked about circles. Okay. Well, let's go back to our text here, which is here for me, and we see there's another principle. If a parallelogram has a right angle and two congruent adjacent sides, then it is a square. All right, and you should reason through that. That seems good. And more principles. Okay, so 3 more parallels, medians and midpoints. Okay, so principle 1, if 3 or more parallels cut off congruent segments on one transversal, then they cut off congruent segments on the other transversal. This is kind of a cool one, right? So that you see the diagram there. So if 3 or more parallels, right? So you have L1, L2, and L3 are parallels here. And if they're parallel in such a way that the transversal AB is cut into congruent pieces A and B, then so will the transversal CD. Any other transversal will also have congruent segments like that. Principle 2, if a line is drawn from the midpoint of one side of a triangle and parallel to the second side, then it passes through the midpoint of the third side. Oh, do we have a picture for that? If a line is drawn from the midpoint of one side of a triangle and parallel to the second, then it passes through the midpoint of the third side. Let me do that in GeoGebra, right? Oh, not that GeoGebra. I want to go here and then say, is this a good one here? Yeah, let's just use geometry. Oh, I've still got that window there. Okay, so I've got the geometry window open, and I want to make a triangle, an arbitrary sort of triangle. I want to construct the midpoint of a midpoint of a side, right? So D is now the, oh, sorry, this is not perfectly centered for you. Okay, oops. Okay, I guess I want to drag that over there and then drag this out here. Okay, so D is the midpoint of AB, and I just did that by construction over here, the midpoint tool, construct a midpoint. And then I want to draw a parallel, a line parallel to BC through D. Okay, so I use the parallel line tools and the little hint at the bottom, which we can't see. Let me move this up. So if I go to the parallel tool, you can see it pops up with select point and parallel line. So I'm going to say, not necessarily in that order, right? Okay, so then I've got the line parallel to BC through D. And this is something you can do with a straight edge and compass. And now I want the midpoint. I also want to draw the intersection. So I want to construct, I guess, an intersection. Segment, where's the intersection tool? I Let's see the intersection tool. Let's see, segment, line, polygon, circle. I guess we can just say choose a point or select position or line, function or curve. If I just point it where that is, it says, yeah, that's the intersection. And to be sure, I can, drag things around and you'll see that it maintains its position there as the intersection. Right. Yeah. And so how do I know that AE, well, this theorem is telling me that AE is congruent to EC, right? And so I could measure. There's a measure tool down here. Measure distance, right? So I want to, and it says select 2 points. Okay, so A and E, that's 4.6 centimeters, I think. And E and C, also 4.6 centimeters. And so those are congruent, and it doesn't seem to matter, where this is positioned. If DE is parallel to BC and D is the midpoint, then E is also a midpoint of AC. So that's what that theorem is all about. Should we go back to our text? Here and here. More principles. So if a line joins the midpoints of two sides of a triangle, then it is parallel to the third side, and its length is 1/2 the length of the third side. Oh, this is a good one, and I think this deserves a little proof. Okay. So I will get out a new sheet of paper, and my pen is probably dried up. So get out a new pen. And, oh, okay. So this is principle. So this is under midpoint median principles. Midpoint median principle. Sorry, principle 3, I believe, is what we're looking at here. If a line joins the midpoints of two sides of a triangle, so the premise is a line joins the midpoints of two sides of a triangle, and is parallel to the third side, then the conclusion is it passes through the midpoint of the third side. Oh, and there's, there's more. Then it is parallel. Can you restart that again? I have this habit of looking away and looking back and then reading the wrong thing. So midpoint principle, this time I can spell principle right, 3 says if a line joins the midpoints of two sides, so the premise is a line joins the midpoints of two sides of a triangle, then the conclusion, it is parallel to the third side and its length is half the length of the third side. So there's two parts to the conclusion, right? One, the line is parallel to the third side. And the other part of the conclusion is the length of the line is half the length of the third side. Okay, so we'd like to be able to prove, oh, sorry, I'm not really in the picture here, am I? Okay, I was making a picture. Okay, so midpoint principle 3. All right, so let's draw a diagram for this, right? So I'm going to draw a triangle. And how do I find the midpoint? Well, I could construct the midpoint by ruler and compass. But that's going to be some trouble, and we're short on time. So I'm just going to measure so that I'll get something that looks reasonably like a midpoint. So this apparently is about almost 3.5 centimeters. So about 1.8 will be the midpoint there. And this is approximately 9.2 centimeters. So 4.6 will be the midpoint there. Okay, so now if I draw this segment here, the claim is that this segment is parallel to that segment. We have to prove that, right? So all I know is that these are equal, and those are equal, right? So from that, I can conclude that so should we put out some labels here? And so DE is, I think that's, yeah, the line segment joining the midpoints of two sides. Okay. So my plan is I want to show that angle D here is congruent to angle A there, right? Then I have corresponding angles are congruent. And how am I going to do that? I think the trick here is, and I think I don't have enough time to redraw this figure. So let's go to, because I don't have enough space, as it turns out, because I have to like add some things to this. So let's go to our GeoGebra window. If I can find that again. And I'm going to say F5 to reload it. Hello, F5. Yeah, it says leave page and then it redraws. So I want a segment, another segment, and a third segment to make a triangle. Then I want the midpoint of this side and the midpoint of that side. And then I want to draw the segment connecting those, right? Okay. So now I can draw a line parallel to AC through B, right? And you might not think of that this is like a good way to go here, but watch what happens. So I need the parallel tool. Where is that? Parallel line tool. It says select a point in a parallel line, right? So I want this point and this line. So then I can do the same thing for C with respect to AB, right? Okay. So I've got that same tool, right? The parallel tool. And I'm going to say this line and this point. And then I want the point of intersection out here to have a name, right? So I'm going to draw a dot there. So that's point F. So what do you know about quadrilateral ABFC? Well, the opposite sides are parallel by construction, right? So that's a parallelogram. Oh, okay. So then I can extend DE, right? And that will intersect CF at this point here, G. So my plan is to show that BD, well, triangle DBE is congruent to triangle GCE. We already have an angle, right? Angle E, those two vertical angles at E are congruent. We know that when the traversal BC cuts parallels AB and CF, it's going to make alternate interior angles congruent. So we have two angles and we have a side, right? Because VE is congruent to EC, right? So angle, angle, side. So we get the triangle, and we don't, I would write this out in more detail if I had more time. But this triangle up here, can I fill the triangle? I would like to fill the triangle. How about I draw it this way? So just to emphasize which triangle I'm talking about here. These two triangles, right? Those are congruent triangles. Oh, so all their corresponding parts are congruent, right? So that means that, well, we can also use that theorem that says when a transversal makes, if you have three parallels, do we have three parallels? Oh, I don't, yeah, maybe we don't, right? We just have the two parallels. BF is parallel to AC, right? By construction. But we don't know that DE, that's what we want to prove, right? That DE is parallel to those as well. But let's see, do I have alternate interior? Do I have corresponding angles? Not yet, huh? Okay, and we are out of time. So let's take up with, I think this is an important proof. So let's take up with this. And can I ask you to just read through chapter 6, the circles triangle, so that we can cover that more quickly? I know we've been going slowly, but we will pick up the pace here. And a week from today, we'll have a little chapter 2 test, or sorry, geometry test. And then we will start in on chapter 2. Any questions before we quit here? We make a list.
I do have questions about the upcoming test. Are we
Yeah.
going to do that more tomorrow, or?
Yeah,
Are you-
tomorrow is, I have office hours, but we won't have class. So on Monday, yeah. I would remind you also that I did post an old exam, an example of an exam here, which is, this one. Yeah. So you can study that. I can also, I think I have the solutions to that, which I can post next week. But I want you to give some time to think about those problems before we post the solutions. And I'll also post the next My Open Math exercise just to have it available. As you're reading chapter 6, you may want to take a look at the kind of problems that are, well, there are a lot of problems in chapter, like solved problems in the text. So, take some time to study that. Yeah. So let me look at the chat here. Will you be making a list of headings that are in the quiz? You mean topics, right? Headings that are in the quiz. You mean the geometry test? Yeah, we'll definitely make sure that we have a review of the essential concepts. I'm going to review everything that involves anything. Yeah, definitely. We'll have some time for review. So Monday and Tuesday, we'll be covering chapter 6. And then part of Tuesday and Wednesday, we'll do review. And on Thursday, we'll have the exam. And I guess it'll be a timed exam. So it'll be during the 70 minutes of class. And, you want to practice, capturing what you write and turning it in. So be sure to respond to the prompt here about scan PDF of proof and attach. You want to see that you can do that, right? All right, anything else? I guess that wraps it up for week 3.
Professor, I have one more question. Sorry.
Yes, go ahead.
Is chapter 6 going to be included in the test?
Yeah, in fact, that's a big part of it. Circles are big. I mean, circles, it's trigonometry is all about circles and triangles. So we've sort of had a lot of triangle time, but now we need to have some circle time. So I'll post, have I not posted that yet? Yeah, let me post that here. And the easy way to get that is to just go to the website. So if you go to this reading and just change to 6, I guess. Yeah, circles. And then I'll copy that and paste it in the new item. So this is just going to be an URL. This URL, and it's going to be circles chapter. It's now at the bottom here, which I need to publish. Okay. Maybe I can move it to the top. Okay, so now it's the first thing here. All right. So what else is on your mind? Is that good? All right. Well, you got plenty to study. You know, take good notes. Try writing up, you know, your 2-column proofs. Look at other people's 2-column proofs, like the one we looked at for the bisecting diagonals of a rhombus. You know, if you just look at, shall I make that site an URL as well? I think, where is that? Oh, that's the oh, that was a good page. Euclid's Elements, that's a good page. Yeah. I get too many tabs going. Erase some of these. I guess I could just find it again, right? Which I don't need that. Don't need that. There's a lot of stuff I don't need here. Back to there. Chapter 4. I guess I don't need that either. Okay, I'm just going to search, what was it, rhombus proof, diagonals, perpendicular bisector. I think it was this site. So it seemed like a pretty good site. Sonoma.edu, I think that's Sonoma State. And there's some professor there with various pages. What if I go back a notch and just say, give me just parallelograms, right? Yeah. Theorems about parallelograms. Sure. So let me post that as a useful resource for you. Do we have a resources page? Different course. Yeah, so this is us, right? And I put in resources here. This video. Mhm. I'll just add it as an URL then. Oh, I want to insert external URL. It's going to be proofs about parallelograms. Add that item and then publish it. Okay. Alrighty, folks. Well, I know I've overstayed my welcome, so I'll be shuffling along. I'll be in my office tomorrow between 10 and 11, as usual. Last Friday I was out of town, so I think I missed that, but I will be here tomorrow. So if you want to talk about things, schedule a little meeting there through the Confer Zoom, right? Appointment blocking, I think it's called.
Thank you, Professor.
Okay, thank you. Have a great day. Have a pleasant afternoon and a fine week.
Take care.
Yep. See you.
Thank you. Have a good
next time.
afternoon.
All right, great. Take care.